Artificial intelligence has moved from research labs into everyday life. You interact with AI whenever you unlock your phone with your face, ask a voice assistant a question, or get a personalized suggestion on what to watch or buy. In this lesson, we'll look at 5 of the most common domains where AI is applied today: computer vision, natural language processing, recommender systems, forecasting, and anomaly detection. But as powerful as AI is, it is not without flaws. Systems can break down when conditions change. They can be difficult to interpret, and in some cases, they even generate outputs that are simply wrong. Understanding both the strengths and the limitations of AI is essential for anyone preparing to work in this field. So in this lesson, we will cover where AI is applied today, key domains such as vision, natural language processing, recommender systems, forecasting, and anomaly detection. We will cover what AI can't do well yet and why understanding limitations matters. So let's begin. So, computer vision. One of the most mature and widespread uses of AI is in computer vision. At its simplest, vision systems classify images. For example, identifying whether a picture contains a dog or a cat. More advanced models perform object detection, where multiple items are identified and labeled within a single frame. A critical real-world application is autonomous vehicles, which must detect pedestrians, traffic lights, and other cars in real time. In healthcare, vision-based AI can help radiologists spot tumors or abnormalities in medical scans with high accuracy. And of course, facial recognition has become a common and controversial application in security and consumer devices. These examples highlight both the promise and sensitivity of vision AI. Its accuracy depends heavily on the diversity and quality of the training data. A model trained mostly on one demographic may underperform when applied to another, raising ethical and performance concerns. So, natural language processing, or NLP. Natural language processing allows machines to read, understand, and generate human language. It's what makes services like Google Translate possible, enabling instant communication across languages. NLP is also the backbone of chatbots and virtual assistants such as Siri, Alexa, or customer service chatbots, which can interpret a user's question and respond appropriately. Another application is sentiment analysis, where companies automatically process thousands of reviews or social media posts to determine public opinion. NLP models can also summarize lengthy reports into short, digestible takeaways, saving people time and helping decision makers act faster. But while NLP has advanced rapidly, it still struggles with ambiguity, context, and cultural nuance. Sarcasm, humor, or idioms can easily confuse even the most advanced models. Recommender systems. Another major application of AI is recommender systems, the technology that suggests what you might want next. Netflix uses recommendation algorithms to surface movies and shows based on your watch history and the behavior of users like you. Spotify does the same with music playlists. In e-commerce, Amazon relies heavily on recommendations to drive sales, showing products that you're most likely to purchase. Social media platforms also use these systems to prioritize posts and ads in your feed. While powerful for personalization, recommender systems can have unintended effects. They can reinforce biases or create filter bubbles where users only see content that aligns with their past behavior, limiting exposure to new or diverse perspectives. This makes recommender systems both commercially valuable and socially impactful. Forecasting and anomaly detection. Forecasting and anomaly detection are two application areas that directly impact business and security. Forecasting uses historical data to predict future outcomes. In retail and supply chain management, companies rely on AI to predict demand so they can stock the right products in the right locations. In meteorology, AI enhanced forecasting improves the accuracy of weather and climate predictions. Anomaly detection identifies unusual patterns that don't fit the expected behavior. This is critical in banking, where AI systems flag potential fraud by recognizing transactions that deviate from a user's normal patterns. In cybersecurity, anomaly detection helps detect network intrusions or malicious activity before it causes widespread damage. The strength of these systems lies in their ability to sift through enormous amounts of data and spot subtle patterns. But the challenge is that they rely heavily on the assumption that the future will look like the past, and that unusual doesn't always mean bad. Pardon me, and that unusual doesn't always mean bad. So limitations of AI. While the applications of AI are impressive, its limitations must be understood. First, dataset shifts. AI models are trained on specific datasets, and if real-world data changes significantly, performance often drops. A fraud detection system trained on last year's spending patterns might fail when consumer behavior shifts suddenly, such as during a pandemic. Second, interpretability. But when many AI systems, especially deep learning models, act like black boxes, they can make highly accurate predictions, but it's difficult to explain exactly why a certain decision was made. This lack of transparency creates challenges in regulated industries like healthcare and finance, where accountability matters. Finally, hallucinations. In generative AI, models sometimes produce outputs that are fluent and confident, but factually wrong. For example, a chatbot may invent citations or provide answers that sound authoritative but are inaccurate. This is a major concern for reliability and trust. Recognizing these limitations is critical to using AI responsibly. It reminds us that while AI is a powerful tool, it is not infallible. All right, so to recap, AI is deeply embedded in our world today, powering applications in computer vision, language processing, personalized recommendations, forecasting, and anomaly detection. These capabilities are transforming industries from healthcare to retail to cybersecurity. But AI has real limitations. Models fail when data changes. They can be hard to interpret, and in some cases, they generate outputs that are misleading or wrong. As future practitioners, you should appreciate both the strengths and weaknesses of AI. By balancing enthusiasm with caution, we can deploy AI systems that are not only powerful, but also reliable, ethical, and trustworthy.